So I'm Matteo Schirmer. I'm a Senior Director of Data Science at Rogers. I oversee data science at Rogers. Rogers is a Canadian largest telco company. And today I'm going to talk how we use data science in marketing. First of all, thank you for choosing me and an early dinner. I really appreciate it, given it's 5 p.m. And let's have some fun. Maybe when I should introduce Rogers. So because most of you will not be familiar, as we only operate in Canada. So we're the largest telco, 11 million wireless customers, 10 million residential home internet customers, probably around 40% converged, so having both services. Telco business in Canada is very competitive. Prices are only coming down for the last couple of years. And generally, it's easy to switch between services. And this makes marketing more difficult, or makes it more important. Okay, and by the way, the talk went, before I could do the talk, I had to go through corporate communications through the slides, so they have been sanitized. So it's more about having a discussion, I think, than reading from the slides. And if you have any questions, just feel free to ask at any point. You know, I'm very happy to take any questions about anything in marketing and data science. Okay, so when you think about marketing, you have to think about it from the customer journey perspective. And you have to think about it from the customer journey perspective, from the data you have about the customer, and from the point of view of activation, like what you can do with a customer. And you start with acquisition, so getting new customers. And typically, this is actually where the data science has almost the least to do, and when it comes to, for example, wireless business, because people, you know, you're targeting almost whole country because everyone needs wireless connectivity, so you actually can't do much. On residential, this is very different. On residential, you're targeting an address. And because we have a third of the country, we know quite a bit about the neighborhood. We know other customers that we have there. We know from Stats Canada, from the census, we know probably around 200 variables about the neighborhood, like how much money people make, what is the demographics of the neighborhood, what is the education people have, lots of things we do know. So on the residential side, we can do quite a bit. So that's with acquisition, and that's the first step. And you would use data science. You would use data science to either direct the field sales, so door knocking campaigns, and that's specifically in residential, or through direct mail. And we have models that will direct people where to go, basically in a different neighborhood, which are the high propensity addresses. So that's acquisition. The things get more interesting as you move to the base management. So managing the existing customers. So when you talk about managing existing customers, there's two things you worry about. So one, you worry about the revenue from the customers, where you try to increase the revenue, and you worry about churn. And I'll talk about churns separately. But when you talk about revenue, your primary activity is upselling customer. Upselling customer with additional services. So let's say you're wireless, and like me, you traveled to US, you might target a customer like that with a roaming package. Or I'm running out of data. Actually, I just got a notification I'm running out of data, and I got a notification that they would like to, sell me a data package. So for those activities, you actually don't care about the churn impacts of those, because you're offering a customer in addition to their services. And actually, that's something they want or something they need. So these are these are very lucrative for the company and very low risk. So that's first part of managing the base. And you would, and generally when it comes to base, you have all the data you can imagine, right? You have all the interactions about the customers they have with you. Second part of base management is managing what can be called a customer lifecycle. So most of the customers these days come in on some kind of a promotion. So the internet will cost, let's say, $100 and they will get $50 off. And what happens after 2 years, you have to, they will roll off promotion, and that would cause a huge churn impact. For you, it will be extremely, you can see 100% increase in revenue. So it might be very profitable. So the problem there becomes an optimization problem where you have certain amount of dollars you want to spend in giving out discounts. You have certain churn you want to keep. And your problem is assigning discounts to the customers according to their churn risk. Okay, so that's managing the base. The last problem is churn. And that was, to me, when I first moved to telcos, quite interesting, that churn is actually a huge problem. So we have 11 million customers, more than 1 million leave every year. More than 10% of our base leaves. We acquire a ton, so like we're net positive, but we are losing lots of customers every year. So it's a high churn business. It's more than 10% yearly churn rate. And when it comes to churn, I guess one thing I should have mentioned, the activation on the base. Base activation is mostly through outbound campaigns. So you send emails, you send text messages, you send app notifications. For churn, this is very different because actually you don't want to give retention campaigns because they are just typically net negative for you because you're losing revenue. You may send out proactive communication to maybe 2% of your riskiest base, but for the 28%, well, because that's what we typically map, you will have a retention offer waiting for them. And when they call in or they come to the shop or whatever that might be, come to the website, there will be a retention offer waiting for them. And the different data science problems, they will all depend on the journey, the data you have, and again, the activation that can be done. Okay, so I'll talk about the platform. My background is data science, so I'll talk about it in the data science context, and I'll talk about it from kind of a different angle. I'll talk about it from the insights that we got as we were building models and what it meant for the platform that we had to build overall. Okay, so what was the first insight we got? So when we were building retention models, what we quickly discovered is that you actually need multiple models, many models, to be able to tackle the problem. And what we currently run overall in the whole organization is more than 130 data science models. And we produce probably around 40 models every year. So 10 models a quarter, meaning we deploy a model every week. And almost any marketing campaign is using models to target customers. There's really no other way at this point. And I'll give you an example on why this is so complicated and requires so many models, because I think this running 100 models is a lot. It's because even the churn problem, where you go to Kaggle and you look at churn problem, and your Kaggle churn problem is who is going to churn in 30 days. That's kind of your typical thing. But when you actually start talking to marketers and you have an organization that runs a churn model for a couple of years, what they actually start to ask questions are along those lines. So we call the 5 Ws. So first of all, they will ask who is going to churn. And you will find that you build your basic model, and then you will find that people that churn on wireless are different than people that churn on residential business. And they are different than people that have both of the services and when those people churn. And even when we look at the segments of population, they will have a different churn behaviors. So for us newcomers to Canada, they churn at 3 times more than everyone else because they get used to being in a new country. They start with a basic service and kind of move on. But even for answering who is going to churn, you're starting to have multiple models. And you do that because every percentage improvement in performance is worth millions at that scale. So that's first question, who? Then you start to answer when. So you start with 30 days, which is a standard thing, but 30 days, it's the most expensive time to save the customer because they're like 1 foot out of the door. They're like shopping already. They're at the end of their contract. It's too late. So what you start to do, you start to develop models for 60 days, 90 days, 6 months, 1 year. And in particular, 1 year is an interesting case where the telco market is very kind of Black Friday promotion heavy. Like actually a large part of our churn, a significant part of the churn happens over Black Friday. And what you end up having is this base that just churns every year. Because every year they will just get a new promotion from someone else on Black Friday. So what you want to do is you want to know, okay, these people in your base will most likely churn every year. And you want to target them with a contract starting, let's say, in June or even earlier. And you put them on a contract and they are safe for, let's say, 2 years. So that's when answering the when question becomes super important. Why? Why they are leaving, or what are the churn triggers? So this is not modeling in the sense of building a model, but as you build models, you learn insights that you have certain events that will cause, for example, 10% churn. So for us, like one kind of example I always give is if you come to retail location and you leave without doing anything, you can have a 10% churn. And the reason is, you came in, you probably asked for an offer, and you probably already checked online, and that was your kind of a last straw. It was like talk to a person to get an offer, you're still not getting anything, and you churn. So what you would want is, one, you would want to have an offers in retail always there, but also you may want to have a follow-up campaign if someone comes in to retail, and then they can get a retention offer reminder when they leave. Where do they go? And that's another interesting problem. So we have the cheap brand, or like the low-cost brand, which is called Fido, and we have the premium brand, which is called Rogers. Like you can think about it as a Toyota and Lexus. And we get people in Toyota, but we want to take them to Lexus because that's where we make more money. And when we build churn models for our low-cost brand, we find 2 types of customers. One, that actually are price sensitive, and the only thing they care is price. So for them, you actually need to offer them same brand. Like they want to stay on Fido, they just want $5 off. That will be the first part that you will build for them. For those customers that want premium services, you want to actually give them a Rogers offer, and what we call it an interbrand offer. So you actually make more money out of them. You tell them, hey, instead of being on 4G, having 20 gigs, we'll put you on 5G with unlimited data, pay us $10 more. And we have specific models that would tell you which customers are likely, that are likely to churn will go to a low-cost brand, and which one will go to the premium brand, and then we target them. There's also activity on the prepaid and postpaid. So you join us on the prepaid brand, which is Chatter, and we want to move you to the postpaid as to have recurring revenue. And finally, what? So what do we do to stop you from leaving? And this comes to the offer optimization. So should we give you $5, $10, $15? Should we give you $200 off on a device? This is all decided on based on modeling. Which device should we offer you? Should it be newest iPhone or certified pre-owned iPhone? Like all this type of considerations go when we create offers. So I'm mentioning all of this just to kind of show you the complexity of this, of even churn. I mean, churn is an important thing, but there's lots of complexity in that. And the requirement that we learned over time is that we had to make the platform basically extremely rigid in terms of the data it consumes and the way you deploy models. Because if you have to deploy so many models in a fairly short time for a large organization, like you can only afford so much flexibility. So it's not, like I remember maybe when I was building first models 10 years ago, it was like YOLO. Every model is like its own pipeline, its own activation, but this just doesn't work if you have to run many models. Okay, so first thing is that you need to have a platform that makes your life easy and makes everything more or less the same. Okay, and these are very common insights, nothing life-changing. Customers that have multiple products, they tend to churn less. Like, very obvious, true for any company probably that sells multiple products. But what does it mean for telco is that, and what we found is that your risk on the wireless business will depend how much data you're using on your residential business, which is not kind of obvious from the first perspective, because but as you put the data together, you're starting to find those insights. What this means is that you have to bring all the data across organization together. And I know this is, it means having a lake, which is what everyone has these days. But also what it meant for us is being able to standardize 5 different billing systems we have. Being able to standardize definitions of revenue, which differ across different billing systems, definitions of discounts, all this kind of stuff that has to now fit into one place. And the other thing we did is we moved from having, and this is very technical, but it made our life much easier. We moved from having multiple tables that data scientists had to manage when building their models to literally having one table or just 2 or 3 tables where all the data is going in and all the models are running from. And that made everything scalable. The telco data is typically small. It's like we have 10 million customers. You never contact telco, maybe once or twice per year. You can go to our website, but again, you don't do anything too crazy there. So you could run this without any cluster. You could, like we used to run it on just one machine for a very long time. But this doesn't work when you start to look into, in our case, wireless cell tower data. So the wireless cell tower data is the data when your phone connects to a cell tower. And that happens hundreds of times for every single customer, meaning we have billions of data points per day. And there are certain insights, like in this case, very simple insight, that the customers that did not activate, like did not log in on the network, bought a SIM card but did not activate, they leave. And you need to be able to send them a reminder, hey, you bought a SIM card from us, would you like a phone to go with it so you can actually start using it? So we had to be able to collate all these data points together, meaning you have to have some kind of a Spark type of environment to be able to run the data, where if you just look on the data on the left-hand side, you probably are fine with running something on your Azure ML instance. On the right-hand side, I will also mention when it comes to the billions of data points, we also look at things like quality of service, which affect your churn. So if you are having a bad quality of service on your wireless network, this would mean that you're more likely to churn. And again, this has to go through the billions of data points to be able to figure that out. I will go back to that simplicity thing I mentioned before. We all abbreviated to one data point, like one score that is then added to the customer table from 1 to 100, which is your customer, which is your QoE score. Okay, high-risk calls are time-sensitive churn trigger. So when you call us and your call is marked as high risk, so when you call center, you typically churn within a day or maximum 2. and your churn goes down over time. But what this means is, we used to run our models maybe once a week, once a month. We have to run our models, depending on the use case, every day or every hour. And that's changed also the requirements on the ETL that we run. So we have to run everything, not in real time, but we have to run everything multiple times a day. Kind of a requirement of a plug to have something on Gen AI. So we do analyze transcripts mostly through NLP, and that's what we always did. So when you call a call center, your conversation will be transcribed, and things that you mentioned, like a competitor name or a cancellation or returning an equipment, whatever that might be, will increase your risk on churn. So we always did that. Your platform needs to be able to handle that. We're now slowly moving to scrapping that NLP pipelines into basically API calls to OpenAI, because that's what it is. The requirement that came from us that we had regarding NLP was that we had to be able to run different libraries and to be able to update those libraries quite often, because the NLP field changed and we had to constantly chase it. And now with the Gen AI, I think this will make our life much easier, because we'll basically outsource all NLP into them. And again, I'm fine taking any questions if anyone has anything at this point. Okay, so this is something that marketers or data scientists really don't care, what I found, which is monitoring part. So the marketers are interested in insights. So marketers want to know that, oh, this person that sneezes on Friday churns on Monday. That's what they want to know. And data scientists, they just want to have fun with data and move on to the next model. And and this is true for every single model we deployed. Is once we deploy the model only gets worse, because the model is a snapshot of customer behavior in time, and then the customer behavior changes, and the model performance, without doubt, only goes down. We found kind of 12 months to 24 months when it goes to more or less random behavior. What this means is that you have to have monitoring, and you have to have performance thresholds where you start to look, okay, I had 3 months of bad performance, which is below my performance threshold that was agreed with the business. Maybe it's time to retrain the model or completely rebuild it, whatever that might be. And that's something I would recommend. We made all of those scores available to the business. So there's a dashboard that they can go to, and they can actually look. So before they run a campaign, they will look, okay, the churn model has, let's say, 60% capture rate. It's good enough to run. And what happened to us for the most important models is that, for example, in churn, the capture rate of that model is actually part of the monthly business review. So it goes all the way to the president, the performance of the model, because it is the key way of targeting our customers. But also, our president knows what is data science at this point, because he had to learn what are the numbers he is looking at. So that's one, is modeling is monitoring the model performance. The other thing is, you will start, and that's something I was not familiar with as much. You will start to see, when you look at model performance, as we do, for example, on a weekly basis, you will start to see random behaviors of models going up and down week on week. And we start to investigate. We had a question, because the performance being investigated by the VPs and whatnot, we start getting questions like, what's going on? This makes no sense. Why the model is working one day and not working the other day? And what we started to find is that we would have intermittent data issues that would last 2 hours. The data would get fixed behind the scenes. but the decisions of the model or the model, like the scoring already happened, and the campaigns already went. And then we look at whether we saved the customers or not, and we did not. And you can't, when you have this monitor, you can't hide anymore with this type of behavior. And we found that these small data issues very often do not cause, like you have some data, general data quality triggers, but they will not cause that for those triggers to trip, nor they will be detected in your data drift, because it's not data drift either. Because data drift is, when, let's say, your contract population changes from 5% to 10%. That's a data drift of your population, but it's not. So what we had to do, and we had to do it for almost all variables of the model, we had to have a very strict monitoring what actually happens to the data, and any issues would then cause alerts. We would then have to gather data, how many alerts we had. We had to go to different teams to then ask them to fix their data, because we're just consumers of other people's data. It was a very long process to make that curve kind of straight. But it is crucial when you really try to have those models run every day. Okay, so these are probably my kind of key insights. Like, this is a very common slide. Like, you will see it on any data architect can produce it overnight. And there's no secret sauce here, but I'll just mention a couple of things. So we move most of our data using Data Factory. All the ETL, a significant ETL is done in Databricks. Data scientists would work out of either Databricks notebooks or Azure ML notebooks, whatever they prefer. Model scoring is happening on Azure ML, and the monitoring, we do have our custom platform for that, or custom set of scripts. We used evidently.ai for some of the drift. And activation, so actually running the campaigns, will be done through all the things that company acquired over time. So Salesforce for field sales, we do have SaaS, we have Oracle RTDM, we have Adobe Marketing Cloud. If I would say anything on this slide that is important, is I would go back to that data architecture and the things I mentioned there on model feature store, targets data store, and model output store. And they're called stores, but they're literally tables. That's what they are. And we really took a long time for model features, for example, to reduce it to the smallest amount of tables we can. So when we have new data scientists on a team, we can just say, hey, these are just a couple of tables you have to learn, and that's all you need to know. If you build any new features, they have to go to that table. There's like no building custom features in your own tables and using that in your models. It has to go to the custom table because, again, we have 100 models running. So it has to go to the same data every single time. For targets, so every model will have a target. So let's say a churn model will have customers that leave. Cross-sell model will have customers that acquire a certain product. Again, we have just one table with all the targets, which makes the building of the model validation and monitoring very easy because it's just a comparison to this one table. And lastly, the model output. So all the model outputs, again, go to, and this is literally a single table, and that's the main interface between us and the company. So we don't give anyone access to anything but that one model output table, and that table is column name, customer ID, and then 100 different scores across all the models. And we have a very tight control who can access that table, and that allows us really to understand how the models are used, because there's some knowledge transfer required to be able to run the models, and it's important for us to know who is running it. And again, it goes back just to a single table. And that's more or less all I had. Thank you, everyone.